Hello students, welcome to Inside Physics. Today we will see one topic in electric potential and capacitance. See, what is actually electric potential? Electric potential is because of a charge and the charge produces electric lines of force. Because of electric lines of force, we need to push a charge if it is placed in an electric field and we need to do some work from one place to another place if we want to move the charge in an electric field. So in this way, electric potential can be defined as the work done to move a unit positive charge from a distance, a long distance, we say naturally infinity, from infinity to a charge and to a distance of r to a charge. So here the electrical potential is defined as potential is work done by Q naught. So see, work done to move a unit positive charge Q naught is represented, and this is a unit positive charge to move a unit positive charge from infinity distance. That means so far away from the static charge. So to a charge placed at some point to a distance nearer r or suppose x, to a nearer distance to a charge is called potential. So potential is basically the work done. So in another form we can also represent potential as Q by R, where R is the distance between a unit test positive charge and a charge. So in diagram we can represent, suppose this is a charge Q and we are bringing a unit positive charge from so far at a distance from infinity to a point here where the distance between these two will be r. So this is a unit test positive charge. So in this way the potential can be represented with these two formulas. So for better understanding, we now calculate the potential due to a point static charge. How to calculate the potential due to a point static charge? Okay. For that, first we will take a unit, a positive charge here. Okay. And we are bringing a unit positive charge from infinity to, suppose, a distance to a point A here. Okay, and we will take 3 points here. I will tell you why. This is point P. Okay, first we will calculate the work done to move a unit positive charge from A to B. Suppose a unit positive charge is here and we are moving from A to B, and from that we will calculate the potential, total potential to bring a positive charge from infinity distance to a point P. So this distance will be x between this charge and the position P. So this distance we will consider as a small distance dx. Okay. So first, what is the electric field due to this positive charge? Okay, at this point P. We know that electric field due to a static point charge will be Q by x square. Okay. So we know that the force experienced in an electric field by a unit positive charge, which is Q naught. See, the charge will be brought here to first to a point A, then we will move a small distance, then we will calculate the potential. Okay. See, the force experienced in an electric field will be E Q naught, right? Here the work done to move the unit positive charge from A to B will be, we will consider it as dW, the small work done to move a small distance will be minus F dx. Work done will be force into distance moved. We know that work done is force into distance moved. So here the negative sign will indicate that the work is done against the force of repulsion. Okay, here there will be some repulsion between these two charges. So here what is F? In place of F we will put 1 by 4 pi epsilon naught into q by x square into dx. If you want to know the entire work done to move a unit positive charge from infinity to point P, we will integrate this equation. Okay, then it will become W is equal to, we'll brought 1 by 4 pi epsilon naught outside the integration. Okay, 1 by 4 pi epsilon naught q by x square dx, right? So here this integration we should do in between the limits infinity to a point r. Okay, infinity to a point r. So in between this is q and infinity to r. So 1 by x square dx. Okay. Oh no, now we will integrate this in between these limits. This becomes q by epsilon naught. What is the integration of 1 by x square? This becomes minus 1 by x between the limits infinity to r. Okay. So here the equation will become minus q by 4 pi epsilon naught. Okay, minus 1 by r minus of, see, in between the limits infinity, 1 by infinity will become 0. Okay, so here finally what the work done will be? The work done will be minus q by 4 pi epsilon naught into 1 by r. This becomes plus. Okay, so q by 4 pi epsilon naught into 1 by r. Okay, see, for this the work done here becomes the total work done to move a unit positive charge from infinity to this point is this one. We know that the work done is nothing but potential, right? So this equation we can write potential is equal to the work done will be 1 by 4 pi epsilon naught into q by r, where r is the distance between these two charges. Okay, this is what we have derived in the beginning. I told you this formula, and this is why, this is how we derive this potential due to a point static charge. Okay, so here we'll move to another system of charges, which is a combination of two point static charges. In a system of combination of two charges, how to find the potential? Okay, see, potential due to a system of two charges. See, a system of two charges means it, a two similar charges placed at some distance apart. So because of that system of two charges, what will be the potential? See, we will see how the system of two charges will be. Q1 and this is Q2. Okay. So the distance between them will be, we can represent it is r with some x. Okay. First, we should find how to proceed to find a potential due to this combination of charges. Initially, we will take these two charges are at infinity distance, both of them. So both are at infinity, and we are bringing these two charges to different positions. We will say this A, this is position B. And if we take a position vector of this, we can consider this as R1 and this will be R2. The vector positions of these two charges. So first, imagine that these two charges will be at infinity distance apart. First, we will bring this q1 charge from infinity to this point A with position coordinates r1. So here, while bringing this charge from infinity to this point, there will not be any other charges present around. Q2 will also be at infinity. So the work done to move a charge from infinity to here will be 0 in this case. That means we can say that potential VA is equal to 0. Okay. And when the charge is placed here, after that we will bring this q2 charge from infinity to this place, and the distance between them will be, we can represent as r12, because the coordinates are r1 and r2. So here the potential to bring this charge from q2 to this point will be VB. We can consider it as VB. Okay, VB. So here the work done to move this charge from infinity to this point will be, what will be the formula we need to use? V is equal to potential difference into charge. That means Q2. Here the charge, what the bringing charge is Q2. We are bringing this charge from infinity to here. This will be the potential, here will be the difference of VB and the potential at infinity. Generally we know that potential at infinity at far away place will be 0. So here we can write work done to bring that charge Q2 from infinity will be VB minus that potential at infinity point is 0. Okay, that is we know VB into Q2. But what is VB potential at this point? We can write VB is equal to, we know the potential, just now we have seen that the potential due to a single point static charge will be 1 by 4 pi epsilon naught into this charge Q1 by R12, right? So this is the potential due to this charge, and this is the work done to bring this charge Q2 from infinity to this point. So here put VB in place of VB here. So this becomes W is equal to 1 by 4 pi epsilon naught VB, okay, Q1 by R12 into Q2, right? So here the work done will be in this form. Okay, work done is equal to 1 by 4 pi epsilon naught Q1 Q2 by R12. 12 means the position vector, the distance between position vector R1 and R2. The distance between Q1 and Q2 is R12. So here the total work done to bring these two charges from infinity to these two positions will be this one. So here also we know that the work done will be equal to potential. So here we can write the potential of a system of combination of two charges will be 1 by 4 pi epsilon naught q1 q2 by r12, right? So in this way we can find the potential of a single point static charge, and if there are two charges present we call them as combination of charges, so the potential will be this one. So this is about the potential and the methods to calculate the potential in case of a static charges. So in the next class we'll proceed to potential of different combination of charges and dipoles. Okay.